Hey guys, welcome back to the channel. Today we'll be solving LeetCode 78 subsets. So we're given an integer of array nums that has unique elements, and we need to return all the possible subsets of nums, and we can't have any duplicate subsets, and we can return it in any order. So what they mean by subsets is, so for example, 1 is a subset of this entire array, 1, 2, 3. 2 is a subset, 3 is a subset, 1, 2 is a subset, 2, 3 is a subset, 1, 2, 3 is a subset. So the array itself is a subset of itself, and we have to basically make an array of all the subsets. So we can solve this efficiently using a backtracking approach. So let's get into the explanation. So the way backtracking works is we're going to use recursion, and in that recursive call, we're going to take in two parameters, an index I, which is going to tell us which index of the array we're on, and a current variable, which is going to tell us the current subset that we're on. So the way this is going to work is we're going to start at the first index. So I is going to be at 0, which is going to be at 1. And then we're going to make some recursive calls. So our current subset is going to be the next parameter. And we can either have, so for the current subset, we can either have nothing in the subset, or we can have something. And that something is going to be what our previous current was, plus the current index that we're on. So like this. And then we're going to keep making recursive calls. So we're going to go down, and this side's also going to go down. So we chose to add nothing here. And in this call, we can still choose to add nothing, or we can choose to add something, but that something is going to be from the next index because we're iterating. So we can choose to add 2. And here we can add nothing again, so it stays 1, or we can choose to add something, which is going to be from the current index, so it would become 1, 2. And we're just going to keep going down. So at the next recursive call, we're going to go on to the next iteration. And this will be better understood when we code, because for the first time you're exposed to backtracking, it can be quite confusing. So we can add nothing, or we can add 3, because we're currently on 3. Same goes for this. And our base case is going to be once the index reaches the length of the array. So if it goes out of bounds, and this is going to be 2, 3, and so on and so forth. This will be nothing because we're not adding anything. Or we can add the current element. Sorry, I'm running out of space here. And here we can add nothing and keep it how it is. Or we can add the last element. And every time we reach our base case, we're simply going to append to our result, which is going to be a variable outside the backtracking recursive call. So we're just going to append to that. So all of these are base cases because I has gone out of bounds. So the next iteration after this, I will go out of bounds, and we're simply going to append each of these to the result variable. And this can be better understood when we get to the code. So we're going to initialize a result variable to an empty array. And then we're going to define our backtracking function, which is going to take in 2 parameters. The index that we're currently on, which is going to be an integer, and the current subset that we're on, which is going to be a list of integers. And this function is not going to return anything. So we can just put none for that. So our base case is going to be if the index that we're on ever reaches the length of nums. And in that case, we can just append to the result. our current subset. And then after that, we can return out of this recursive call. Then we're going to make 2 more recursive calls. And in these recursive calls, we're going to increment the index by 1. And we can either add the current element that we're on to the subset that we have, like this, or we can just simply go to the next index and keep what we already have. So this is what I was explaining in the explanation. We can either keep what we have or add the current index that we're on. And this is the whole backtracking function. It's not that difficult. Then we just have to call our backtracking function with 0 and an empty array. Our subset starts as an empty array and the first index is 0. And after that, we can just return the result. Let's see if this works. Looks like it worked. And as you can see, it's pretty efficient.